Hey friends, welcome back to the channel. If rational expressions still mess with your head, no stress. We are gonna make it super simple today. But quick heads up, if you haven't watched part 1 yet, hit pause and check that out first. We have covered the basics and 7 key examples that will totally help you understand what's going on here. Link is in the description, go watch it and come right back. Alright. If you are all set, let's dive into 7 more questions that will help you get the hang of this topic once and for all. Let's roll. In this video, we will be dealing with these 7 questions, which covers almost all possible questions from the topic. Let's start with the first question. Simplify these expressions. Do you remember the first step of the simplification? Yes. If possible, we factorize all the denominators and numerators. In this question, numerators are already in the simplest form, so no need to factorize them. But we can factorize all 3 denominators. Let's start with the first denominator, x squared minus 3x plus 2. We split the middle term. That means by using the 2 factors of 2, 2, 1 is 2, we form 3. So since there is plus at the end, so we add them, means 2x plus 1x is 3x, open the bracket, so minus and plus multiplies and this becomes minus. And from the first pair, take x common, so there remains x minus 2. From the second pair, we can take minus 1 common, so x minus 2. Finally, our 2 factors are x minus 2, x minus 1. Likewise, the denominator of second fraction can also be factorized following the same way. By using the 2 factors of 6, we have to form 5x, 5. And in front of 6 there is plus, so we need to add those 2 factors. 3, 2 is 6 and 3 plus 2 is 5. So 5x will be split into 3x and 2x. Now if you open the bracket, plus 2x becomes minus, and then take x common from the first pair, there remains x minus 3, 2 common from minus 2 common from the second pair, so there remains x minus 3. Ultimately our factors are x minus 3 and x minus 2. Likewise, the denominator of third fraction is x squared minus 8x plus 15. We have to factorize 15. That means 5 times 3 is 15. And since there is plus in front of 15, means by adding 5 and 3, we have to get the middle term, that is 8. So 5x plus 3x is 8x. If you open the bracket, you'll get minus in front of 3. And from the first pair, x is taken as common. From the second pair, 3 is common. Ultimately, our factors are x minus 5 and x minus 3. This means we have factorized all of 3 denominators and we have got the factors that needs to be substituted in the denominator of each fraction. Let's substitute these in the denominator in second step. Okay, x squared minus 3x plus 2, we got x minus 2, x minus 1 from here. And then for the second fraction, we substituted from here. And for the third fraction, we substituted from this. After factorization, the second step is, if possible, cancel the same factors from the denominator and numerator. So x minus 1 and x minus 1, they are same factor. Again, x minus 2 and x minus 2, they are same factor. X minus 5 and x minus 5, they are same factor. Let's write the remaining. Now, let's compare the denominator. X minus 2, x minus 3, x minus 3 means the denominators are unlike, right? In order to make the fraction like, we need to multiply the first fraction with x minus 3. And second and third fraction, we need to multiply them with x minus 2, right? So let's multiply. Here, I multiplied the first fraction with x minus 3 both in the denominator and numerator. Second and third fraction with x minus 2 in both numerator and denominator. If you have watched the part 1 of this rational expression series, then definitely you easily understand what I've done over here. After that, see, we have got the like fractions, all the denominators are same. So we perform the simplification, means we just multiply and simplify the numerators. Now, look at here. This x plus this x plus this x means x plus x plus x. 3x minus 3 minus 2 is minus 7, right? Okay, so I'll write that as my last step because 3x minus 7 comes in the numerator, it cannot be further factorized, so this is our answer. We are done with the first question. All right, let's jump into the second question. Simplify this expression. Again, while simplifying this one, we recall the 3 steps. First, factorize the denominator and numerator if possible, right? And first and second fraction, we cannot factorize, they are already in the simplest form, but the denominator of third fraction can be factorized. A square minus b square is a plus b, a minus b, isn't it? So we'll replace this with these two factors, okay? I haven't done anything new except factorizing the denominator of third fraction. Now, thus I multiplied the first fraction with a plus b in both denominator and numerator. Second fraction with a minus b because if the denominator of this fraction lacking this factor, the third fraction I've kept it as it is. Now we have got the denominators same, means you can simply perform the operation in numerator. See, a plus b times a plus b whole square, a minus b times a minus b is a minus b whole square, and the numerator of third fraction I've kept same, and the denominators, since they are like, so I've written only one. Now a plus b whole square, we can expand the formula. A minus b whole square, also we have formula, so we can expand it in the next step. A plus b whole square, a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square, and other things I've kept same. And one thing you have to be careful is, since there is minus in front, so either you have to multiply inside with minus and write at once, or keep it in bracket and write it in the next step. That minus has big role here. See, I just wrote the first one same because there was plus in front, and here minus in front, so this minus and minus multiplies and 2ab becomes plus and b square becomes minus. Finally, this minus a square and plus a square becomes 0, plus b square and minus b square becomes 0, minus 2ab and plus 2ab becomes 0. That means I'm left with 2ab in the numerator, and a minus b, a plus b is a square minus b square, isn't it? So 2ab by a square minus b square is our final answer. We are done with the second question as well. Let's jump into the third question. In this question, we are again supposed to simplify this expression, but this is different than what we have done before, right? Okay, again the first step, we factorize the denominators and numerators. We cannot factorize the first denominator, we cannot factorize the second denominator and the numerators as well because they are in the simplest form, but we can factorize the denominator of third fraction. Let's factorize the denominator, okay? X power 4 plus x square y square plus y power 4. What we do is, we write x power 4 and y power 4 together, and we convert x power 4 into x square whole square and y power 4 into y square whole square. Now, I believe you know the formula of a square plus b square, which is a plus b whole square minus 2ab. Here in place of a, we have got x square, in place of b, we have got y square. So, x square plus y square is x square plus y square whole square minus 2ab, 2 times x square times y square, plus this x square y square remains same. Now, x square plus y square whole square I have kept as it is, but 2x square minus 2x square y square plus x square y square becomes x square y square. And x square y square is xy whole square in the next step. Now, see, this one, the terms inside the bracket acts as a, and this term inside the second bracket is b. Now it has become a square minus b square, right? So expand it, a plus b, a minus b. In place of a, there comes x square plus y square, plus b means xy. Again a minus b, a is x square plus y square, minus b is xy. Finally, if we keep this xy in the middle, then we will get x square plus xy plus y square, x square minus xy plus y square. If you factorize this expression, you'll get this one as your factors. X to the power 4 plus x square y square plus y to the power 4 equals to x squared plus xy plus y square times x square minus xy plus y square. So this is the standard formula you can use wherever you feel necessary. Okay, so in this place we can replace by these two factors. Let's do that. I have copied the first and second fraction same, but in third fraction denominator is replaced with the two factors. Now we make the denominators like, see, I've just multiplied. Now the denominators are same, we can perform operation in numerator. Let's move to the numerator of first fraction. X minus y, x squared plus xy plus y square. Is this the expanded form of any formula? Can you guess? X minus y times x squared plus xy plus y square. Very good. It is x cubed minus y cubed, right? Second one, I think you can guess it. This is x cubed plus y cubed. So in place of these factors, we'll replace the x cubed minus y cubed and x cubed plus y cubed respectively. And the third one will copy the same. Since the fractions are like, so we write only one denominator as our LCM. See? Let's open the bracket. There won't be much changes in the numerator. I just open the bracket. Now this minus y cube and plus y cube, they will be cancelled out. X cube plus x cube is 2x cube and then 2y cube in the next step. Now we can take 2 common in the numerator. Same thing I've done in the next step. And finally we got x cube minus y cube. We again have to expand this x cube minus y cube. Can you please tell me the expanded form of x cube minus y cube? This is x minus y times x squared plus xy plus y square, isn't it? Finally, this x squared plus xy plus y square, I can cancel from the both numerator and denominators, and my answer will be 2 times x minus y divided by x squared minus xy plus y square. Let's roll into the fourth question. Simplify this rational fraction. Again, this is different than what we have done before. All the questions that we are doing here in this video are different. And these questions cover almost all possible questions from this topic, remember. Okay. Here, if possible, we factorize, right? Let me do for only one numerator, okay? In the numerator of first fraction, we have got a squared minus b minus c whole square. Let, if you are confused, then you can consider b minus c is x. Then how does this look like? A square minus x square, isn't it? That means a square minus b square. It will be a plus b, a minus b, isn't it? But x is b minus c. So x can be replaced with b minus c and a minus b minus c. But this minus multiplies and becomes b plus c. This is how we expand. This two terms inside the bracket will act as one single term and will expand as a square minus b square, okay, in all of these fractions. So if you have to factorize the numerator of second fraction, then it becomes b plus a minus c and b minus a, this minus multiplies and c becomes plus. Okay, we follow the same technique and factorize all the numerators and denominators in second step. Okay, see what I've done? A plus b minus c, a minus b plus c. In the denominator, a plus c plus b, a plus c minus b. Just expanded as a square minus b square, which I depicted just before. Now, if possible, we cancel the same factors from numerator and denominator, right? Look at here. In the denominator, I've got a plus c minus b. B is minus, a and c, they are plus, right? B minus, a and c plus means even though their position is different, order is different, they have same symbol, means we call them like factors or same factors, so we can cancel them, okay? This one and this one. Likewise, this c is minus over here and this c is minus, isn't it? A and b, they are plus, a and b plus in the numerator, means this factor and this factor, they are same, just their position is different. Look at here, in the third factor, a is minus and this a is minus in the numerator. B and c, they are plus, b and c are plus. This one and this one, they are also same factor, you can cancel them out. Now write the remaining factors, okay? So whatever is remaining, I've written them, okay? And look at here in the denominator, a, b, c, they are present in all three and they are plus, means they are same. If the symbol was different in front of them, then we would call them different. But the symbol present in front is same and the alphabet are same, only the order is different, means they are the like, they are same. So no need to further make them like, as they are already like fraction. Just operate in the numerator, okay? I just operated in the numerator. Now let's cancel the term that can be cancelled out. Minus b plus b plus a minus a minus c plus c. So what remains in the numerator? A, b and c, right? Okay, a plus b plus c in the numerator and a plus b plus c in the denominator. Cancel them out. You'll get 1 as your answer. Let's do fifth question. Simplify this expression. This rational expression involves square root. And the first step we have to factorize, right? But all the denominators, they are in the simplest form. But again, this third denominator, we can factorize it. But rather than factorizing the third one, I will better do the first two factors first and do with the third at last, okay? I think that will be easier for you. So we will simplify these two first. And once we complete our simplification, then we will do with the third one. See? First fraction I multiplied with 1 plus root a. Second fraction I multiplied with 1 minus root a. Okay, now since I'm working on the first two fractions and I made the denominator slide, so let's work on the numerator. I'll multiply with 1. 1 into 1, 1. 1 into root a. So what happens? This 1 into 1 again in 1, minus into this minus plus root a. And in the denominator, since the denominator has slide, so I've copied only 1. Now look at here. Minus 1 and plus 1 is 0. Root a plus root a is 2 root a. Okay? And 1 minus root a, 1 plus root a. A minus b, a minus a plus b means a square minus b square. So I've done same thing in the next step. See? Root a plus root a, 2 root a. 8, 8. 1 minus root a, 1 plus root a is 1 square minus root a square. Okay? So what happens over here? 1 square is 1 itself. Square and root removes means there remains only a. So finally, I'm left with 1 minus a in the denominator. And the good news is, denominators of both the fractions, they are same now. They are like. Means just simply perform the operation in the numerator, okay? 2 root a plus 2 root a in the numerator and denominator write only once. Now, see, 2 root a, 2 root a. If you add them, 2 plus 2, you just add the coefficient, so it becomes 4 root a divided 8. And 4 ones are 4, 4 twos are 8, means you'll get root a divided by 2 times 1 minus a, which is our answer. Even though the rational expression involves square root, the simplification doesn't look that difficult, right? Okay. Let's move to the sixth question. We are supposed to prove this rational expression, okay? Simplify the left-hand side, reach to the right-hand side. That is the process. So let's write the left-hand side first. We need to simplify it and we have to reach to the right-hand side. Now, on the right-hand side, I need to prove 1 minus a to the power 4. Means 1 is in front, a is in the back, right? But here, in the denominator of first term and second term, a is in front. It's better to change in the form of our right-hand side. Means 1 and a square. 1 in front and a square at back. Okay. So, for the denominator of second fraction, I'll be taking minus common and keeping 1 in front and a square at back. See, if you take minus common, then this minus 1 becomes plus and plus a square becomes minus a square. Why I have done this is because our answer contains 1 in front and a at back. So I want to make my expression the same form. Okay, that is the first step. Now this minus and this minus multiplies and it becomes plus. And if you factorize 1 minus a square, then it becomes 1 square minus a square, which is 1 plus a, 1 minus a. I'll do that in the other step. See? Just the symbol is plus and then 1 plus a, 1 minus a. Since I'm working on the first two, so I need to make these two denominators same. I multiplied the numerator with 1 minus a and the denominator with 1 minus a. And I have kept the third fraction same. First two they are like, so simply perform the operation in the numerator, keeping only single denominator as the LCM. Means this 1 plus a, 1 minus a is 1 square minus a square, which is 1 minus a square. 1 into 1 is 1, minus a, plus a. And the second fraction I have started factorizing over here. 1 is 1 square, a power 4 is a square whole square. Because we need to factorize it at the end. So we haven't factorized it at the beginning, right? So we can start over here. Now, minus a and plus a becomes 0. So first fraction contains only 1 by 1 minus a square. And second fraction, see, 1 square minus a square whole square. A square minus b square. A plus b. A means 1 plus b is a square. A minus b. 1 minus a square. Now, we have to make these two fractions like. Even though we can factorize it further, we will not. Because our first fraction has 1 minus a square in the denominator. So, if you want to make the denominator same, just multiply the first denominator by 1 plus a square and the numerator also with the same. That means 1 times 1 plus a square, and in the denominator there comes also 1 plus a square. Finally, look, the denominators are same, means the fractions are like. So you can simply write the one denominator as LCM and perform the simplification in numerator. Means 1 times 1 is 1, 1 times a square, and this minus and a square comes in the numerator. Now, plus a square minus a square becomes 0, right? So, what happens? In the numerator there comes only 1. In the denominator, 1 minus a square, 1 plus a square. It is the expanded form of a square minus b square. So let's write that. 1 square minus a square whole square. 1 square is 1, a square whole square is a to the power 4. This is right hand side, which we were supposed to prove. See? We started from the left hand side, we simplified, and we reached to the right hand side, means we proved the given rational expression. Prove this rational expression. Again, if we have to prove it, then we start from the left hand side. So here, the denominators of the left hand side and right hand side, they are not in the same form. See, in the left hand side, a is in front, but in the right hand side, x is in front, right? So for the first two, we have to change them into x plus a, x square plus a square, okay? But since both the terms, they are plus, so we can change whenever we want. No need to take minus common, okay? One thing that we have to do over here is we have to start from the back. See, this is because this x power 4 and a power 4, they involve minus in between, means we can factorize it, but we cannot factorize a square plus x square and a plus x. So we'll be taking the last two first, we'll be simplifying them. Afterwards, we move to the first one. So this is the reverse one, okay? If both the denominators in the expression are plus and you cannot factorize, then start from the last, okay? Let's do that. X power 4 minus a power 4, it can be factorized as x power 4 is x square whole square, a power 4 is a square whole square. So a square minus b square, you can write x square plus a square times x square minus a square, okay? Let's write that. See, x square plus a square, x square minus a square. Since we are working with the last two fractions, so we make them like, look at here. I multiply 2a with x square minus a square, likewise the denominator with x square minus a square. Now these two fractions, they are like, they have same denominators. So just simplify the numerators, keeping only one denominator in the name. What I did over here is I've written only one denominator as LCM. 2a into x square is 2ax square, 2a into a square is 2a cube, and this 4a cube remains same, okay? Now what happens over here is minus 2a cube plus 4a cube is plus 2a cube, isn't it? So I'll write same thing in the next step. See, 2ax square remains same, minus 2a cube plus 4a cube is plus 2a cube. Now 2a is common in both, right? So you can take that 2a common. I've done over here. You can take 2a common from the numerator, and there remains x square plus a square. Now x square plus a square and x square plus a square, you can cancel them out. What remains? 1 by a plus x plus 2a by x square minus a square. And you know, x square minus a square is x plus a, x minus a, isn't it? So you can factorize that way. Now, make the denominator same. We need to write x plus a over here, okay? X plus a, you need to multiply it with x minus a, and the numerator again with x minus a. So what happens? See, 1 times x minus a, x plus a times x minus a. Again, the denominators are same. That means just multiply and simplify the numerator. X minus a plus 2a. Minus a plus 2a is, of course, plus a. Now we can cancel this x plus a and x plus a. Ultimately, you will get 1 by x minus a, which is the right hand side. We proved. And that's it. We just crossed 7 questions together. If anything is confusing or weird, just drop a comment. I've got your back. And of course, hit like, subscribe, and stick around. More math magics on the way in part 3. Till then, keep practicing and keep being awesome. See you in the next video.